I'm working on IBM Cloud Kubernetes service, and I mainly take care of the storage responsibilities in the container cloud. It's developed based on Kubernetes platform, and my role is on the storage side. So let's move on to the agenda. So today's agenda is mainly broken into three pieces, three logical parts. The main part will be the microservices. I'll be touching base upon what are microservices and why are we using that in the cloud, in a Kubernetes based cloud, and how it is different from our traditional services that we use. And then the next topic I'll be touching upon is monitoring and logging. This is very closely related with the microservices. Mainly when we deploy some services in our cloud, this plays a very important role in mainly debugging any of the customer issues. And the second thing is monitoring, where we want to capture some of the important metrics of our apps. So all this plays a very important role in understanding how our app is performing and how the high availability is working, and all those different metrics. And the last one is I'll be having some small demo where I'll be showing the deployment of this microservices in the Kubernetes cloud. I'll be using IBM Cloud for the purpose of this demo. And this will be some community based WordPress app. It's a very popular app, as everybody knows. So here we'll see the deployment of microservices and how we use the monitoring and logging as well in this app. So let's move on. So to start with, why do we really need to use the microservices? What is the difference? So these are some of the features that we see here. Like it is useful for rapid delivery, and it will be useful for high availability, scalability, and resiliency. These are some of the very common terms we have heard in cloud when we talk of cloud. So when you come to the traditional monolithic services, where it's a one big service, and it will be very difficult to scale. If you have to even push out a small feature or a small bug fix, it is a very longer cycle to manage the scalability and even high availability there. And if you have to do some small development or periodic development, it is not so faster. The life cycle is a very bigger life cycle there, and so we'll lose out on time. And mainly in today's world, where we all talk of agile or DevOps, and it should be very rapid delivery for all the features. So that's one of the reasons why we moved to cloud. And in the cloud we have a new concept called as microservices. So basically this is going to replace the traditional monolithic services that we are used to, and I'll be explaining that now. So what are microservices basically? So it is nothing but it is just a new engineering approach, where it is if I go back to the old world, it's like a divide and rule. So in our traditional services, we had one big app, whether it is WebSphere or any other app. If you just consider the legacy applications, it is a one big app, and it will have a lot of features, and it will be having an army of developers, testers, integration testers, everything as we are all aware of. It's in the traditional model. So in that case, here if you see on the left hand side, I am depicting one monolithic application where you have one big app, and it will have several different components or modules, and it will be managed by one big team. So here the difference is when you want to do some updates. Here I'm just taking an example of version 2. So you want to upgrade to a new version and provide it to your customers. The cycle will be spanning, it's a very long cycle, where you have to do the requirement analysis and then do the development and testing, integration testing, and everything. So so for one new version to come out, it will take sometimes maybe months, 1 or 2 months or more than that. So that is not really acceptable in today's world. It's a very rapid world, as we all know. So now what microservices is bringing in here, the same app will be broken into in this format, where you can see there are the same three different components in this example are actually broken up, and they are running as different microservices. So when I say microservices, they are all containerized. In this monolithic thing, it is one single app used to run up in the enterprise side, and it will come up and it will be running. But here it will be containerized, where all these different components are built as Docker images, and they are deployed in your cloud, which is based on Kubernetes. So here if you see, there are three different components, all are running on different versions, and they are all managed by a small team of developers. So this is a different methodology, where most of us might have heard agile or DevOps, right? So where each team is responsible for doing the development, testing, deployment, and taking care of any bug fixes. So each team will take care of their respective component which is deployed as a microservice, and they will be responsible for handling the queries. So the main difference, how these microservices will communicate with each other, because for the end user or the end customer it will be one endpoint which will be hitting. Here, for example, there will be some one web interface or web link which will be used by the customer, but that will be the entry point for this app. One of the microservices will have that entry point as the endpoint, and then internally those microservices will communicate with each other. The communication model, there are multiple things. There can be REST based communication or gRPC based communications, which is based on sockets. So different teams or different companies use different methodologies. But the thing is, all these different microservices will have exposed their interfaces. So when one microservice is talking to the other one, it will be talking based on the interface. So whatever the development or the new features that we roll out, it is not really impacting the other microservices. So if there is any new feature we have to roll out or a bug fix, you simply fix that particular microservice and push it into the production, and a new version of that will come up and it will be running. But for the other microservices, the communication will be seamless, where they will be still talking to the interfaces. So they just give some input and get an output, so that will not change for them. So this is how it is becoming very, very beneficial in terms of cloud, and everything we are trying to do are microservices today, where every app will be deployed as a microservice, and that is the benefit of this. So any queries on this? I'll just pause because we are moving to the next section. Sorry? With the microservices, I don't really see any flip side, because it is always giving all the different benefits. It is reducing your development cycle time, or the production, the push to production time. And if you see now, the entire development cycle will be reduced to a matter of few days, or maybe 1 week or 2 weeks. So as we work in that. Yeah, that is actually the benefit or the beauty of microservices, where in the first model, if you see, there is one version, but to manage that one version you will need a very big team, and each teams will not be aware of the different components involved in that one version, right? But when you come to the microservices, it works in a very small teams, typically 5 to 10 member teams, and they are only maintaining their one microservice, which is easier to manage, because now you have broken it into small pieces. So managing small pieces for a small set of developers is much beneficial.
So she has a question that do we have any duplication of the code, like while breaking the code? That's a question?
Yeah, so basically when we are talking of microservices, we are breaking it up into different logical components. So if I just take one example, in a typical app you might have a networking component or a storage component, or a database service which is running, and a front-end service, right? So that is actually, those are logical components which are broken, which are self-sufficient. So they cater to the entire request response mechanism within themselves. They are not dependent on other microservices for their functioning. So the duplication will not happen, because that is a totally different component, the other microservices, that is. Yeah, the dependency is more towards communicating with the microservice. For example, you get a request for one microservice, and now that will perform its functions, and it is done from within their set. For example, if you take a database service, it is stored the data and it has done the transactional part. Now it will be calling some other app, that is a dependency. So that will not be a database app, that will be some business app, some business tier microservice.
We will be using the same data transfer objects, but coming to microservices, if we split the UI and the DB call as a separate microservices, then the forms they will be duplicated, right?
When you say duplication, I mean, as I said, it will be broken into logical components. So no two microservices will perform the same operations. Okay. So if you take in the old way, you also had different components, right? They used to talk to each other. There were dependencies on each other. So the dependency was very closely coupled there. Yeah. So you have to bind them as some in the old way, some jar file or enterprise stars, and then you deploy that. Here they are all developed independently. So all these microservices are not dependent on each other, and you can manage or repair or fix for any particular microservice and independently bring it up.
Just to add on here, like what I know is, so your application doesn't go down, like as a
Yeah.
whole application, only a component of it goes down. So you get an advantage of, like only a component, like storage goes down or anything goes down. You can.
Yeah.
Sorry, one more. Okay, so when you get into microservices, especially when you have a mesh of services, for the user, they really don't care whether you do microservices, you do monolithic. So when you have a mesh of services, whether one service goes down, two service goes down, or three or how many ever out of 100, to them the overall experience could be broken depending on how critical that service is. So that probably will not change by going to a microservices model, one thing. And the other thing being that if we go back to, say, object-oriented design, where single responsibility principle is something which is advocated, not probably so much implemented, if you see, they could probably, each microservice is just an object, because every object is expected to adhere to an interface and the other objects use them. So they are not as different, because even in enterprise world, different people own up to certain pieces of code. It's not like one person knows the entire piece of code, so it is not so much of a different idea. And for a flip side, there could be a lot of serialization, deserialization happening. What do you want to tell about that? Because like what she was commenting about, if you're sharing objects in memory, you don't actually incur that. But then if you start serializing, deserializing one piece of data across maybe 6 services, 7 services, that could be quite a lot of latency, even with the best of code.
Yeah, so to answer the first part of your question about the application coming down or one or two microservices coming down, so the way it is developed in cloud is it will have high availability, meaning when you push something into production, you will have a stages, right? You will first push your new changes or code into some different environment. They call it as A/B testing, or there are different terminologies. So basically, you push it into a separate branch inside the production where it is more tested first. It is like a beta version, you can say, and only once they capture all these, that is where the metrics come into picture. So once they capture all the metrics and they analyze and they see that the new code that we are trying to push is stable, only then they move it to the mainstream. And then even in the mainstream, they phase it out periodically, wherein you will not have a downtime, because in Kubernetes you will have replicas of your microservices where there will be multiple replicas running. So it will be phased in such a way that the old one will be just coming down and the new one will come up gradually. So the end user experience will not be broken in that way. So that is how it is managed in the cloud scenario, because most of the clouds, if you have heard, they give this 99.999% of availability. So that involves all the clouds, whether you take AWS, Azure, or IBM cloud. Everybody is developing in the similar fashion, all these microservices, and yet we see all this in the official records that we are having 99% plus of availability. That is achieved only because of this kind of architecture, and it is already now there in the industry. It is not a new concept, it is there for last few years, and it has been proven by many customers as well.
We can take this offline. It's a subjective discussion, I guess.
Yeah, sure.
Yeah.
So let's move on in the interest of time. So the next topic I'll be touching base upon is monitoring. So monitoring is nothing but its collection of metrics. Now we have deployed our microservices in the cloud, and there will be various metrics we want to collect. Basically, this is to analyze how we are performing as a microservice. It depends on the nature of your microservice, because the metrics is a very subjective matter. So if it is a network based service, you may have some metrics like how much request how much request I'm serving, or what is my response time, and what is the downtime, or what is the failures I'm getting in my service. So these are some examples I'm just giving. So in case of IBM Cloud, we have used Sysdig for monitoring. Sysdig is a third party basically, so it's a partner of IBM, and they have a very good monitoring and troubleshooting system within them, and that is what we have integrated within IBM catalog. So basically, you deploy Sysdig from the IBM catalog, and that will be deployed as a that will have its agents which will be deployed on your cluster, on the Kubernetes cluster, and that will finally fetch the metrics from your microservices or all the apps that is running on your cluster. So this is based on the metrics side. So I've just posted one screen of how the Sysdig screen would look like. This is capturing metrics. Like you can see here, it is having some request count, HTTP error count. So these are some of the sample metrics I'm just displaying here. So the next one is logging. So as I said, logging is one very important component for any app, whether it's microservice or any other app. This is more important. This comes more into the picture when we have some customer issues, when we want to debug the issues, right? So in case of IBM, we are again partnered with LogDNA, which is having a logging product, a logging service. And so whenever we earlier had our own logging service, but then LogDNA provides a lot of features where you can filter out your logs, and you can easily debug your application or your microservices, whatever the issues are there. And hence we are using LogDNA in IBM Cloud. We will be seeing all this in the demo shortly as well. So now I'm coming to the demo where I'll be providing some brief about this. Today for the demo I've taken WordPress app. This is one of the very popular website management app or content management app, and most people might be aware of this who are using the cloud. So this will here we will see how WordPress app is deployed. There are multiple microservices in the WordPress app. So I'll just show that diagram. Yeah. So here you can see in the diagram the architecture of the WordPress app, how it is there. So here we can see there are two microservices. One is the front end, which is the WordPress app itself. That is one microservice, and the other one is the database service, which is the backend. That is another microservice which is deployed here. And then you can see on the left hand side here is the customer or the web user. So he will basically invoke some web-based URL, and the flow goes to the WordPress app, and it will save some data in the database service, and it will revert back. And similarly, the user may store some non-text related data like photos, videos, or any other stuff. So that will be stored in the WordPress app. The WordPress is having its own persistent storage here, and that is a persistent storage for the database app. So this is how this microservice architecture we'll be seeing in the demo, and we'll also see how we are capturing the different metrics and logs by using monitoring and logging. So if you want to develop one microservice, for example, as I said, a big app is broken into multiple microservices, and each of those microservices is actually managed by a small team of developers. A team could be typically in the range of 5 to 10 members of teams. And then breaking down to the development phase. So if you have a new microservice to be developed which has a particular requirement, so then that requirement will be broken up into the different sprints. So typically teams work in a 1 week sprint or 2 week sprints, which is more in the industry what I have seen. So all that work will be divided in that particular team. So each team will be responsible for its own microservice, and their work will be divided among the different sprints, and then it will be delivered independently of the other microservices.
Any other questions on how you can start using microservices? Because every other app these days, like Flipkart, be it Flipkart uses microservices a lot. Every other app is switching to microservices. Why is it switching? Because sir has already explained, you don't design a monolithic application anymore. Okay, you divide it into services, components, and then render it. So any questions?
So if there is a microservice, let us say X, and if it has 4 or 5 versions of it, can we run all the versions?
On how we manage it, right? So when you say microservice, if it is for example a REST-based URL, it is having a REST-based endpoint, right? So you will have some REST endpoint or a URL where you will invoke. That is where I told initially for the other question, how we ensure that we don't get broken, right? So there we will have different versions, like a V1 and a V2 version, for example. So now you have rolled out a V1 version, it's there in the production and everybody is using it. But now you want to roll out a new version called V2 with some enhancements or new features into your service. So what typically is done is it's called as A/B testing or blue-green testing. There are different terminologies. So you roll that out in a different route in your production. When I say different route, it's a different path. So you will have some URL slash v1 slash something. It will be v2 slash something after that, right? So there will be a difference, and the end users or the customers who want to use that, they can use with the new REST endpoint and they can try it out. This is how the IBM Cloud dashboard would look like if you have a IBM Bluemix account and you log in. So here as part of the demo, first I'll be going to the catalog, and I want to set up my cluster with the monitoring and logging. That is a prerequisite for me. So here, as you can see, I am trying to set up a Sysdig agent on my cluster first, because when I deploy my WordPress app, it has to capture the metrics and logs. So here I'll be taking some trial version of Sysdig just for the demo purposes, and I'm creating a new instance here. So once you choose Sysdig and you create an instance, the next step is we have to set up that Sysdig agent on our cluster. So basically it will deploy as a daemon set on all our worker nodes in the Kubernetes cluster. So this is what we are seeing in the demo here. We are trying to set up a Sysdig agent, and we'll see we'll be using the command line for just running this Sysdig agent setup, and then we'll also verify that the agent is installed and it is activated. So here now we ran this command. This is all in the documentation of IBM Cloud, which you can get it. So we have installed the Sysdig agent, and we are trying to verify this. As you can see, it's running as a pod in IBM Observe namespace. So this is basically a daemon set pod which is running, and we will also verify in the UI where you will be using your Sysdig actually. So here when you come to in the UI, you navigate to the monitoring section. You will see that we have a new Sysdig agent which is deployed, and it is also activated now. So it is ready to capture the metrics. So it will be capturing all the metrics of all your containers, apps, network based metrics, storage metrics, and everything that is there on your cluster. So you can also do the customization of that based on the requirements, like what metrics you want to capture, or if you have some custom metrics, even that can be enabled here. So now we are seeing the setup of log DNA. That is another logging agent, as I said. So we are creating one trial instance here, and we want to set it up for our cluster, and after that we will be good to capture the logs. So it has some prerequisite steps, like it has to create a logged in agent, and then we give the instance details as in a Kubernetes secret in our cluster. So we are creating the secret, and then we are creating deploying a daemon set where it will use those instance details of our agent. So it will be actually pushing the logs into the log DNA. So now we see the logged in agent is also up and running. So everything is containerized here as we speak. So every agent or every app that we talk is basically a container in the backend. So we'll verify this in the UI again, where we'll be seeing in the logging. We navigate to the logging section, and we see that our logging agent is successfully deployed and it is actively running. So this is where we are confirming here. So now we move on to our deploying of the WordPress microservice app on our cluster, where we will see the different microservices which will be deployed, and then we will also see the metrics and logs flowing into those apps and how it will be useful for debugging our applications. So I am using the community Helm chart. This is available in the community. It's a WordPress Helm chart where we will be deploying the WordPress app using the Helm charts here. And we'll also see the different resources that are getting created as part of this microservice here. So here the WordPress app will be using MariaDB as a database service. The actual database will be MariaDB in the backend, and the WordPress app will be the front end tier actually. So as we are seeing, there are different resources created here. You can see the deployment, config map, the pods, secrets, and this is all actually inside the Helm chart, and these are it is actually encapsulated in the Helm chart, which is easier to deploy. And now we are just verifying the different pods. So you can see there are two pods running here. One is the WordPress pod, the first one that is actually WordPress app, and the second one is the MariaDB the backend data service app. So both of these are actually microservices. They are running as two different pods on our cluster, and we are just waiting to see the pods coming up. So so now we are seeing that one of them has come up, the database service, and we are just waiting for the WordPress app also to come up, and then we'll be invoking the WordPress app from our browser, and we'll see the data flowing in our logs and also the different metrics that are being captured. So this is one of the important points I would like to highlight here. So this is the microservice which we are seeing. So now I have deployed the microservice. There are two microservices. As you can see here, there is a WordPress and the MariaDB database service. And now for the end user, how he will invoke this. So he will be invoking based on some public endpoint. He needs to have some external IP address to invoke in the web interface. So here we have configured the WordPress app, which is having a load balancer. And if you see, there is a private network with a private IP which is mapped to some external IP. So only one of the microservices is having the external endpoint. The other one doesn't have it because that is not exposed to the end user or the customer, right? So we are having an external IP for the WordPress app here, and it is launched based on different ports. We have enabled it on HTTP port 80 or even HTTPS port, that is 443, and internally it is mapped to our internal port using the node port stuff in the Kubernetes. So this is the microservice details which we are seeing in the cluster, and this is how we will be using this external IP to deploy this, to invoke this app in the web interface. So now we will go to the browser and launch this WordPress app, whatever we just deployed. So as you are seeing, we have mapped the port 80 to the internal port 30611 on our container using the node port, and now we have launched this microservice app. Basically this is hitting our WordPress app which we just deployed on our cluster, and it is having some sample data. So now I'll add some sample data here so that we can see this data coming into our metrics or onto the logs. So how the database service is being used, and then basically from the database service it is stored on the logs. The app is having its own logs, right? So all those logs are getting pushed to the log DNA from the backend. So I'm launching the logging service now here to see the logs, whatever has been generated till now. And this is how the log DNA UI or the dashboard would look like. And here I'm using a trial version, but in the paid version you will have a lot of features. You can do the filtering of the logs based on different filters or text. So these are some of the sample logs we are just seeing. I'm trying to add some filter here based on the comment that we added. So here we are just seeing the logs using Kubernetes. We are seeing the logs of the WordPress app, and this is how the logs look like. This, most of you who have used Kubernetes might be familiar with it. So now the same logs will be flowing to the log DNA, and here you can have a lot of filters based on date, based on specific text, or based on some things that you're looking in your logs, which will be helpful in the debugging. So I'm trying to add a login filter because I did a login to the WordPress app. So I'm trying to see the login related logs here. So we're just waiting for it to come. So I'll just do the login because it's a trial instance. It is not persisting the logs in logDNA currently, but I'm just doing the relogin, and now I will see the logs flowing. So as you can see, I just did a login again to the WordPress app, and you are seeing the login related logs in the logDNA. This is a very simple thing which I am showing, but it is having much more useful here. You can filter the logs based on the container types or the namespaces or a particular file in the logs. So all the container logs of your cluster are getting pushed here in the logDNA basically. So it will It will also involve sys logs or any other logs which we need on the system side, which will be useful for the debugging. So now I'm launching the sysdig dashboard here. We are switching to the metrics part or the monitoring part. So as you can see here, these are the different namespaces of our cluster and the different containers or pods coming here. So we can see the metrics for the entire cluster, as I said. But here we will be trying to see the WordPress app related metrics, whatever the metrics are pushed by the WordPress app. So these are the different services I'm showing. So we'll shortly move to the dashboard, and these are the different types of metrics you can see. So we are just going to see the HTTP based metrics here, and these are some of the default metrics that is coming with the sysdig monitoring. But as I said, you can also add your custom metrics as the need, based on the need, and you can see those metrics also in this UI. So these are some of the metrics which we are seeing. This is the metrics for the entire cluster without any filters, for all the containers, for all the storage that is present, the different metrics that you are seeing. So now we will see add a filter, and we'll filter out on exactly what logs we want to see. So we'll be trying to see the WordPress related log based on, these are the different filters you can add based on container name, labels, or apps, or even Kubernetes based filters you can add. So there are a lot of features which you can use to filter your metrics. So we will be checking the filters based on the container name of our WordPress, because we gave the name as WordPress in our container. So I'll try to filter based on that. So here I've just used a Kubernetes label, and these are the different labels present in my cluster. It will pull all the labels and it will just show me, but I'll be moving to the container name here, and I'll be trying to filter based on the container name. And these are all the different containers which we are having in our cluster. So now we want to see WordPress containers metrics. So as you can see, this is the WordPress containers metrics which is coming up now. So it has different request count, what is the topmost URLs that is being hit. We mostly have the login URL here, so it will capture all these metrics, the slowest URL and everything. These are just some of the default metrics which we are seeing, which can be customized. And here if you come to the services section, we will see that in the default namespace we have our WordPress service microservice which is deployed along with the database service. So if I want to see the WordPress app related metrics, these are some of the metrics which we can see: the request count, the response time, the network related metrics, and all these things. So yeah, I think that's all from the demo perspective. We can open up for any Q&A now.
Okay, and if we see that some containers are getting, say one of the servers, some containers are utilizing more of the resources, do we have something like movement of containers or something?
Yeah, here you can configure all those metrics. Those are some of the custom metrics which I spoke about. So as we saw in the demo, you can see individual services or even individual pods, or it will come all the way down till the individual containers. So you can see individual containers metrics also, like what is the CPU it is taking, and I think here we are seeing.
Can we change it from here?
Yeah, you can change it here. You can filter. So basically, as by default, sysdig is capturing the metrics of all the containers of that particular worker node. And similarly, all your workers will have their own sysdig agents, and they will be all pushing it to a particular endpoint.
Okay.
And that will be showing as a consolidated view here.
No, what I'm saying is, if we want to restrict the CPU usage of a container, can we do it from here? When it's just collecting the data, can we push it also and enforce that thing?
This is mainly only for collection of metrics.
Only for collection.
If you want to enforce some limitation or restriction, then that you have to do from the deployment perspective.
Deployment.
So if you have a deployment file for Kubernetes, right, there you can mention the CPU limit.
No, what I was coming out to is like dynamically can we change it using sysdig, or next version of sysdig can be dynamically changing it if they see the resource utilization is not correct, or it is already done.
Okay.
Or you are trying to.
This is not for from sysdig. You can't push anything. This is mainly a monitoring tool.
Okay.
Where it is monitoring the health of your cluster, like which containers or pods or services is using more resources.
So do you know any software which does the dynamic changing of the things, or it is already there in Kubernetes? Any such software, or you can suggest
I'm
me?
not aware of anything
Sure.
in the Kubernetes at least, where when the pod is running you can dynamically change it.
Okay.
So the way you can change it in Kubernetes is, if you have some pod running, you can edit the deployment, and you can enforce your restrictions there,
Sure.
and it will redeploy the pod immediately
Yeah.
within a matter of seconds.
Yeah.
That will have the new limit enforced on it.
Thanks a lot.
Hi Akash. So
Hi.
thank you so much for this session on microservices with Kubernetes. I had a question. So you talked about sysdig,
Yeah.
and I understand that monitoring would probably be very important and maybe different in the way that we do it in microservices as compared to monolithic services. I just wanted to know, besides sysdig, could you share what are some other monitoring services that are out there?
I think Prometheus is one thing which is, yeah, we have Grafana and Kibana, and all. Kibana is for logs. Yeah.